So in this problem, we are determining the components of the support reactions at a fixed support. And if you remember, at a fixed support, we have three support reactions. We have Y, we have X, as well as a resulting moment, because this is a fixed joint. If we had a pin, there would be no moment, right? So how do we figure out what the Y and X are? Well, we draw a full free body diagram where we have Y, X, got 6 kilonewtons down there. We got 4 kilonewtons pointing out there. And we're going to identify some of our angles and distances. So how do we find our X, Y, and Z? Right, we have three equations: net force in the X, net force in the Y, and we'll go down here for our net moment. And each of these are going to be equal to 0 because we are in static equilibrium. So for the x-axis, we have a positive x plus 4 times cosine 30. And so x ends up being negative 3.46, and our units are kilonewtons. And the y-axis, we find that y minus 6 equals 0. So our y reaction is just 6 kilonewtons. And for our final part, we have the moment. And for the moment, we have a little bit of a tricky problem, right? Because we have a couple of angled members. So we have to be really careful about how we handle that. So our first moment, we're going to take it around point A. That means that we have negative m, because our m is in the clockwise direction, and that is negative. We have negative 6 kilonewtons times a distance of 1.5 meters. And then we have two components for this 4 kilonewton force, right? There's an x component and a y component. Let's start with the y component. That's again going to be negative. It's going to be 4 sine 30. That's our y component. And the distance, well, that's 3 meters for this straight portion. And then we have this sort of angled beam. And we only want that x displacement of that angled beam. So what we end up doing is we add to our sort of x distance. Well, what is the x component of? We have a hypotenuse of 1.5. We have a 30. So we're going to do 1.5 times cosine 30, and that just comes from our triangles. And this is our y component, the moment created by it. Then there's the x component, right? 4 cosine 30. And that is applied at a y offset of, well, we only have this one beam. That's going to be 1.5 sine 30. And so we find that our moment is negative 15. And our units are going to be, well, kilonewtons times meters. Now we got a negative here. All right, our two x's, or our x and y, our x was also negative. So when we go back and if we were to express our final answer, well, our x is actually pointing in the wrong direction, so we have to change it. Our y was in the right direction, and our moment was also in the wrong direction, and so we can just rearrange them. And so we've got 3.46 kilonewtons, 6 kilonewtons, and a moment of 15, right? So we're going to drop all those negatives by just flipping the direction. And that makes our drawing just a little bit simpler and easier to understand. So that's going to be our reaction forces for this problem.